Hello there everyone, and welcome back. And I've got one more video I want to deal with while talking in this book. And oh, I didn't even do it. Sorry guys. This is the Jack of all trades with the foul mouth, Commodore Urban. And there's one more thing I want to talk about Lionel's post-war F3s before we move on from this subject. And I want to talk about the repair and maintenance of these locomotives. And there's a very good section here that deals with it, repair and maintenance. And I'm going to read this to you, and I'll show you diagrams and shit that are in here too, so that you guys can maybe learn from it and shit, and maybe not, if you ever get a original set of F3s, you may not, have to worry about fucking it up. Okay, it says here, the F3 was and still is a very reliable model and a fine runner. However, nothing was made to run forever, and the locomotive does require occasional lubrication and maintenance. If you follow the directions given in the Greenberg's Lionel post-war operating instructions with layout plans, the F3 should give you hours of entertainment and performance. Occasionally, however, mechanical and electrical devices fail. When that happens, you will want to refer to your copy of Greenberg's Repair and Operating Manual for Lionel Trains, 1945 to 1969. Yes, I have it. This includes exploded view diagrams of the single and dual motor versions, including part numbers, wiring schematics, and brief descriptions on some of the key changes to the locomotive. Assuming that you have the reference material available and some mechanical and electrical aptitude, I will offer tips on repairing some of the F3's most common or toughest problems, both mechanical and electrical, that I've observed over several years of repairing Lionel trains. During the post-war era, Lionel produced 3 different F3 chassis, or frame styles, for use with all the road names they offered. Specific changes were introduced from year to year, and the author of this book has covered those in detail. I'll describe the basic repair principles, and you should be able to adapt them to specific unit on what you're working on. In describing the 3 versions, I usually refer to the representative Santa Fe models because so many people own this locomotive because it was cataloged along with any other F3. Let's see, the 3 chassis styles are represented by the 2333, the 2343 and 53, and the 2383 dual motor units. The single motor units are identical to the 2383 type chassis. Okay, now the first problem here is the wheels and the magnetic axles. A problem can occur with the original Lionel powered iron wheels and magnetic axles used on the 2343/53 and the 2383 chassis. The steel used for the ends of the magnetic axle can actually enlarge the hole in the powered iron wheel to the point where it will eventually spin freely and even begin to wobble. This wheel, part number 2343-33, can easily be replaced from many sources. An axle end itself can also become loose from the stainless steel tube it is encased in, along with the core of alkyl magnetic material. When the glue and rolled edges become weakened because of the torque of the running for a long time, sometimes after removing the wheel and cleaning the area with denatured alcohol, you can flood the end of the axle with CA, which is acrylic adhesive or superglue, and strike the stainless steel tubing with a chisel just enough to hold it in place. For a more permanent repair, drill a small hole through the end of the axle and stainless steel tubing at about a 15-degree angle. Insert a piece of piano wire into the hole and secure with epoxy, trimming it to fit. If neither of these approaches work, you'll need to buy a replacement part. This process can become confusing since the axle is usually sold with a wheel mounted to it, and over the years Lionel listed their manuals several wheel and axle assemblies designated with a variety of purposes. For example, magnetic axles were designed to pass through a worm gear were different from those that did not. Those passing through a worm wheel were sledged or curled, and those not passing through a worm wheel were non-sledged or non-curled. The part number for the magnetic axle is 2343-78, replaced by 2353-29 for the sledge and 2353-30 for the non-sledge, but they have been shown as part number 622-143, 623-10, 623-13, or 2328-175 for the sledge magnetic axle assembly, and 622-144 or 2343-70 for the non-sledge axle assembly. Now, brittle wire. Another operational concern is the wire leading from the collector assembly to the lug on the reversing unit. Over the years, the rubber-coated wire Lionel Postwar units have become stiff and brittle. Replace the lead from the collector assembly to the reversing unit terminal lug, and from there to the first motor with stranded PVC wire. If the stranded 3-wire cable between the motors looks tired, replace it as well. Shrink tubing purchased at an electronic supply store will cover the 3 leads nicely, insulate them completely, and cut down on the clutter inside of the shell. The motor frame rivet. The rivet that holds the field coil to the motor casting frame often becomes loose, most likely due to vibration, electro-oscillations, or even poor riveting during the manufacturing process. This problem is mentioned in the manual for the 2333 back in 1949. Occasionally, poor operation of the motor may be due to mechanical interference between the field and the armature caused by loose riveting of the field limitations. The problem can usually be corrected by tapping the star-shaped area of the rivet, point A, on the accompanying diagram with the large end of a ball-peen hammer or a large flathead 12D or larger nail. Which, there you go, there is the diagram so you can see it. Do this with the brush plate removed and the field coil resting on the jaws of a vise. Make sure the threaded part of the rivet is firmly held by the vise jaws. Otherwise, you may push the rivet out of the field coils, loosening the laminations, eventually contributing to a noisy motor. I usually heat the area of the reshaped or flattened part of this rivet to relax the effect of cold working the metal. This prevents it from cracking later. I sometimes even add solder to the area. Acid flux with plain solder and thoroughly clean to prevent the corrosive effects of the acid flux. Now, commutator fix. Over time, carbon brush deposits tend to build up in the commutator slots and short 2 or more segments of the armature together. This carbon greatly slows down the motor and causes considerable heating that can lead to the burning of the motor completely. You'll notice this phenomenon where one power truck is running slower than the other. Another identification is a halo of fire visible through the hole between the brushes of the field plate. A trick I use is to fill the slots with the commutator with 5-minute epoxy. Make sure you reface and smooth the commutator face after the epoxy sets. Otherwise, the brushes will bounce, resulting in poor contact, eventually causing the brushes to chip and wear sooner than normal. Alright, lubrication. Lubrication is critical for proper operation of the locomotive. However, for lubrication to be effective, it's important that you remove the grease, grime, and grit and shit that have accumulated since the mechanism has last been cleaned, especially if it has been several years since the locomotive has been operated. The long-term evaporation of lubricant actually leave a varnish-like coating on the surface, and you might just as well lubricate a fucking plastic part. I added the fucking in it myself. Also, many of the currently available lubricants and synthetics are incompatible with some of the old materials, and old lubrication actually accelerating the problem. I have found that good mineral spirits is the best solvent for soaking most of the old lubricants away. Do not use lacquer thinner, as it will dissolve the varnish coating off the wires off the armature infield coil. And I do mean soak. I leave the power trucks and motors in it for a couple of hours, if necessary, before hitting it with a toothbrush. Be sure to work with solvents only in a well-ventilated area and away from open flames. Also protect your eyes and skin while working with the solvents. Then I flush the solvents off with a spray of hot soapy water briefly and blow dry the parts with a hairdryer. When the mechanisms are thoroughly clean, I apply label number 108 oil and number 106 grease to the location specified in the service manual. Lots of grease and oils will work. The key is to make sure whatever brand you choose is safe for use with plastics. The label or packaging will let you know. Also, applying lubricant sparingly. Excessive lubricant will eventually spray over the inside of the locomotive shell and work its way down to the wheels and track. Now finally, the horn. Perhaps the worst thing you can do is leave a dry cell size D battery inside the locomotive. This is the most common problem we find with F3s. Damage caused by a leaky battery. It makes a mess. Always remove those batteries, especially if the unit is going to sit around for a few months. There is no such thing as a leak-proof battery, and once the damage is done, there's little you can do to repair the mechanism. Replacement becomes the only option. Like in that picture there. That poor 2343 did not have a chance. So yeah. And there you go, guys. That is all the maintenance tips from the Lionel's Postwar F3s. I hope that will help you guys with maintaining these really powerful locomotives and keep them running for years to come. If you have any questions or comments about what I've read or talked about, leave it in the comment section below and I will try to answer you. And if you're new to my channel and you like what I'm doing, hit the subscribe button and turn on notifications, and you become part of the Commodore's crew and get to see when I upload new videos. Until next time, this is Commodore Urban saying let the track be clear ahead for you and full speed ahead. And God bless you. You take care now, alrighty? Good day.